Welcome back, and in this video we're going to look at some examples that discuss series and their convergence or divergence. So just some examples. This first one, I'm going to do the first two and then you're going to do the other ones. But this first one, if we look at it carefully, this is the same example as we saw in the previous video, but this ends up being an infinite geometric series. So we know that this is this is convergent, okay, by infinite geometric series with r, which is 3/5, being less than 1 in absolute values. Okay, so then if we want to find its sum, we would say that we can use the formula for the infinite geometric series sum. Do the first term over the common ratio. Common ratio is 3/5. First term ends up being 1, so then I end up with 5/2. Okay, that was fun. Okay, next one. This doesn't look like a series at first hand, but if we're careful, I believe we could say that this is the series from I is equal to 1 to infinity of, and then let's see, 2 times minus 1 to the k, and then times 5/4. Oops, I should use I here. I used I as a subscript. There we go. To the I minus 1. Okay. You can double check it, but this ends up being the case. And because of, so it looks roughly geometric, but number one, we have this r, this common ratio being bigger than 1, and we also have this alternating term, which we don't know how to deal with. This is going to be divergent. Okay, and if you wanted to cite a reason, you can say r is 5/4, which is bigger than 1. Okay, that's fine. Okay, moving on. Next one, I want you to try. Okay, the next two I want you to try. And here's what I got. So in the first one, you have to do a little bit of separating so that you have the same exponent. So if you factor 4 to the n as 4 times 4 to the n minus 1, then you can write it as this, which then means it's a convergent series because the common ratio is -3/4. Okay, and you get 1/7 as a result. This one, really, we're just saying that r is √2, and √2 is 1.4-ish, and which is bigger than 1, so it's divergent. Okay. Now, for this next one, I kind of want to talk about this. We see this thing, and we're like, oh my goodness, well, it's probably going to be convergent, right? Because it's 2 over n squared, and the sequence is going to be convergent. What about the partial sums? I don't know. So here's what we need to do with this one. If we are careful, we recognize that, oh, the denominator, that's going to factor. How is that going to be productive? Why do we care? This is going to be 2 over n plus 3, n plus 3 times n plus 1, right? Okay, and then I can say, oh, well, I can do partial fraction decomposition, but again, why is that useful? Okay, plus b over n plus 1. And I'm going to skip the algebra. You're welcome to do it out on your own. But I end up getting that b is equal to 1 and a is equal to -1. Okay, so then really what I can say is that this whole thing here is the series n is equal to 1 to infinity of -1 over n plus 3 plus 1 over n plus 1. Okay. Okay, again, not immediately useful. Why is this useful for convergence or divergence? Well, here's the thing. What I can do is I can start writing this out. Okay, so this would be the same as saying, like, okay, I have, put in 1, I get -1 over 4, or 1 over 4, okay, plus 1 over 2, okay, that's fine. And then the next one I would do, so now n is 2, so I have -1 over 5, plus 1 over 3, okay, not immediately useful. Moving on, okay, -1 over 6 plus 1 over let's see, okay, 1 over 4, and then plus negative 1 over 7 plus 1 over 5, okay, and then so on and so forth, right? Well, now here's the beauty of this whole thing. You can see that I had a positive fourth and negative fourth somewhere in the sequence, right? So this ended up canceling with this, and then later the 1/5 ended up canceling with the negative 1/5 ended up canceling with the 1/5. And if this is an infinite sum, right, I could say that the 6th is going to cancel eventually, the 7th is going to cancel. So at the end of the day, what I'm left with is the 1/2 and the 1/3. So really, all I have to do is add 1/2 and 1/3. And let's see, last time I knew this was 5/6. So that's actually really useful. And if we needed to find the sum, we could say it's convergent or divergent using the definitions, right? We have, the limit of the sequence is 0 and the partial sums. I'm sure we could show that that's convergent, but if we wanted to find the sum, that guarantees convergence as well. So this type of series is very, very well known in mathematics, and you're probably going to see it more than once. This is when you can do partial fraction decomposition and get things to cancel like this in the sequence, we call this a telescoping series. So be on the lookout for this one, telescoping series. Okay, we'll likely have one in group work, and I'm sure you'll encounter one of them somewhere in your homework.